Architect Divya Chakravarti. She completed her undergraduate studies from SRM University and she went on to pursue her master's in historic preservation and urbanism and study of the built environment from the University of California, Los Angeles. She went on to work for the Department of Planning and Preservation for the city of Pasadena, California. She also did a brief stint of work for Historic Scotland, Edinburgh, UK. She had also worked on conservation projects like Kalsa Mahal, Gokhale Hall in Chennai, and Marimalappa Educational Trust in Mysore. She is currently working as a director of Samrakshan Heritage Consultancy. She is also a co-founder of the Artisan Reprisal of Traditional Materials, Method and Technology. She goes on to conduct workshops to revive traditional and lost methods of construction.
Welcome to the UGC lecture series for Bachelors of Architecture. The subject we are looking into is environmental science. The topic we are delving into is environmental pollution. In this lecture, we will be looking at thermal pollution, nuclear hazards and solid waste management. Now, what is the source, cause and effect of thermal pollution? Increase in normal temperatures of natural waters caused by the intervention of human activities is referred to as thermal pollution, because temperature is basically a physical characteristic of water which is regulated under the Clean Water Act. Areas in certain parts of the globe are supposed to reflect certain types of temperature. The water should reflect certain types of temperature. Because of some anomalous activity, if this temperature is risen, it is referred to as thermal pollution. Causes and typical ways we see thermal pollution as an effect: suffocated fish, altered food web, decreased fish population and low dissolved oxygen. So, once the temperature of the water rises, certain animals and plants thrive in a particular optimum temperature. Even a 1 degree difference makes a huge alteration in their life. So, certain fish species may not be able to survive. The amount of oxygen that is dissolved will reduce. That causes again certain fish to suffocate, and this alters the food web. So, the typical source and effect is right here in this image. Major causes are nuclear power plants, deforestation and soil erosion. Discharge of heated water or hot waste material into water bodies, let it be from nuclear water power plants, industrial effluents, domestic sewage, hydroelectric power, coal-fired power plants. Nuclear power plants use water as a cooling agent. After the water is used, it is put back in the water supply between 9 to 20 degrees C. Emissions from nuclear reactor increase this temperature of the water bodies. Coal-fired power plants, coal is utilized as a fuel. Condenser coils are cooled with water from nearby lakes or rivers. The heated effluents decrease the dissolved oxygen of the water, and this therefore damages the marine organisms. Industrial effluents, discharged water from steam electric power industry using turbo generators will have a higher temperature ranging from 6 to 9 degrees C than the receiving water. In modern stations producing 100 megawatts, nearly 1 million gallons are discharged in an hour, which increases the temperature of the cooling water passing by nearly 10 degrees Celsius. Domestic sewage, sewage is commonly discharged into lakes, canals or streams. Municipal sewage normally has a higher temperature than the receiving water. Increase in temperature of the receiving water then decreases the dissolved oxygen again. Then besides this, the foul smelling gases increased in water results in the death of marine organisms. It could produce really serious gases and poisonous gases like methane. Deforestation, the decrease in vegetation increases the amount of light that hits the water, which increases the temperature of the water. Deforestation also increases erosion. So, this is more like a indirect way of cause. Soil erosion makes the water muddy, which again increases the light absorbed, and the previous point follows through. Hydroelectric power generation. Generation of hydroelectric power sometimes results in negative thermal loading in water systems, which means it creates less heat on water sources. than the nuclear power plant. Now, this is dissolved oxygen versus temperature. You can see dissolved oxygen versus temperature. As the temperature there is an increase, there is a significant drop as well with the percentage of oxygen. So, that has to be seriously taken into account. When 30 degrees is there, it drops so much more, when as versus it is just a mere 10 degree. So, within 20 degrees there is a steep drop in dissolved oxygen. Fish oxygen use versus temperature. Again over here, oxygen consumption versus temperature. As the temperature increases, the fish require more oxygen to sustain, and because again the dissolved oxygen gets lesser, fish end up dying. So, this is a very complex relationship which can be understood very easily. Typical response to temperature. You have the Pacific salmon to goldfish. You can see the solid dot which you see over here is the upper lethal limit for a given species, and the open dot that we see is the best temperature for spawning or reproduction, and the solid blocks that you see here is the preferred temperature range. And you can see the pathetic state of the shad. It is getting very close to their extinct temperature, and again over here a couple of these species are getting closer and closer to the lethal temperature where these species will just stop existing. So, we need to ensure that thermal pollution is curbed completely to ensure all the saving of these kinds of creatures and other supporting marine life like plants and other large fish. Effects of increased water temperature. Thermal shock. Aquatic life adapted to a certain water temperature can go into a shock even if the temperature changed by 1 or 2 degrees Celsius. Oxygen dissolved in the water decreases, increases the rate of photosynthesis, which increases the amount of plant growth, developing eutrophic conditions. Increases the metabolic rate of the fish, which increases the need for oxygen. Biotic effects of thermal pollution. Changes in the environment may also result in the emigration of organisms to another, more suitable environment, and to in-migration of organisms that normally only live in warmer waters elsewhere. As a result, one has a problem of compromising food chains of the old and new environments. Biodiversity will definitely be decreased as a result. Species will start changing their ability to adapt to the environment, which is the survival of the fittest. That is the principle of evolution. Even man tends to adapt himself to suit the best environment possible, and even creatures will start doing that, which will reduce migration, and once migration reduces, a lot of other effects will also happen. Changes of even 1 or 2 degrees Celsius can cause significant changes in metabolism and other adverse cellular biology effects. Principal adverse changes can include rendering cell walls less permeable, which makes osmosis difficult, coagulation of proteins difficult, and also alteration of enzyme metabolism occurs. These cellular level effects can adversely affect mortality and reproduction. How do we go about controlling thermal pollution? Cooling ponds, man-made bodies of water designed for cooling by evaporation, convection as well as radiation. Cooling towers which transfer waste heat to the atmosphere either through evaporation or a heat transfer. Cogeneration, which is basically a process where any kind of waste heat that is recycled for domestic or industrial heating purposes. Cooling towers, cooling ponds, spray ponds, and creation of artificial lakes. So, these artificial lakes won't have any other job but to just act as a buffer zone between the receiving water and the effluents that are getting discharged from the different plants. Moving on to nuclear hazards, their source, effect and control. If you look at the history of when nuclear hazards and fission came into being, was in the year 1938 in Germany when they bombarded uranium with neutrons. So, Fermi demonstrated that chain reaction in a nuclear pile or reactor in Chicago was completely put across in paper and in action, and that was the first atomic bomb or the nuclear bomb under the Manhattan Project in New Mexico. $2,000 million was the budget estimate for the Manhattan Project. The test explosion was in 1945 and it was considered a complete success. That is the history of the first nuclear bomb and nuclear fission that was recorded. The test explosion was a complete success. Then the bomb was dropped as a weapon on Hiroshima, the second on Nagasaki. The bomb had the power of nearly 20,000 tons of TNT, and Hiroshima nuclear explosion killed nearly 100,000 people, and another 100,000 people were permanently injured and disfigured. This is considered the worst risk managing effect in the history of mankind. Now, if you go about defining what exactly is a nuclear hazard, there is nuclear pollution and hazard is pretty much the same, because this as such is a new reaction that is entered our environment. We have started using nuclear reactors only recently, let it be for production of energy or as a weapon or whatever use. So, any kind of risk or danger to human health or the environment posed by radiation emanating from the atomic nuclei of a given substance, or even a possibility of an uncontrolled explosion originating either from a fusion or a fission reaction of atomic nuclei. If you look at nuclear hazards, radioactive pollution or nuclear pollution is a special form of physical pollution related to all major life supporting systems. This encompasses air, water and soil. Radioactivity is the phenomenon of emission of energy from radioactive isotopes, that is unstable isotopes such as carbon-14, uranium-235, uranium-238, 239 and radium-226. Any kind of emission of energy from radioactive substances in the environment is called as radioactive pollution. Generally, radiation hazards in the environment comes from ultraviolet rays, cosmic rays, visible microwave radiation. Amongst these, X-rays which produce about 95% of radiation exposure. Nuclear energy or power plants is used to produce electricity, but fuel used in power plants is considered radioactive, which is very dangerous, and waste material is considered very hazardous. Now, fusion is a nuclear reaction in which atomic nuclei of very low atomic number fuse to form a heavier nucleus with a massive release of energy. A fission reaction is a reaction in which a heavy nucleus splits spontaneously on impact with another particle, again with a huge amount of energy. So, nuclear power is being used worldwide for the generation of electricity. Now, we are obviously looking for alternatives for fossil fuels, but our alternatives again cannot be equally hazardous. 17% of the current electricity consumption comes from nuclear power. Typical sources of nuclear hazards: natural sources are cosmic rays from outer space. The quantity depends on altitude and latitude. It is more at higher latitudes and higher altitudes. Emissions from radioactive materials from the Earth's crust. Man-made sources include nuclear power plants, X-rays, nuclear bombs, nuclear accidents, mining and processing of radioactive ores, use of radioactive materials in nuclear weapons. Pathways of exposure to man from release of radioactive materials, internal dose from eating and drinking radioactive material and water, which is from food and water. This could be from well, again from underground water. It could be from the cow and the milk or the meat. It could be from the fish and the water again. External radiation directly from the cloud. Internal dose from inhalation of radioactive materials in the air, and external dose direct from radioactive materials which is deposited on the ground. Natural sources encompasses about 81%, which includes radon about 55%, which is external, cosmic and terrestrial, and internal, which is K40, C14, etc. Man-made sources encompasses a mere 19%, but again that is on the increase steadily, which includes medical, that is diagnostic X-rays 11%, nuclear medicine 4%, consumer products and others, which includes fallouts, powered plants, air travel, occupational, etc. Now, the effects of nuclear hazards it can be divided as 3 groups: short term recoverable effects, small effect which leads to like loss of hair, long term irrecoverable effects, and finally genetic effect which gets transferred even to future generations. Internal bleeding, blood vessel damage may show up as red spots on the skin. Cancer is considered to be a major health issue from radiation exposure. Radiation can cause changes in DNA which is known as mutation. Acute exposures appears as burns, radiation sickness, that is nausea, hair loss, weakness. This is the biological effects of ionizing radiation. If you have somatic, that is affect the individual exposed. Genetic is it affects even the next generation. This is basically because of chromosomal mutations. Immediate effects that we see are radiation sickness like vomiting, acute radiation syndrome. Delayed effects that you see are leukemia, that is blood cancer, carcinogenesis, which is again different forms of cancer that can show up later on, fetal development abnormalities, and shortening of life. If you look at the different effects of radiation on humans, 0 to 50 hour there is pretty much no visible effect. 50 to 200 you have brief periods of nausea on the day of exposure. 50% of this may experience radiation sickness, nausea and vomiting. No death as such is expected. 200 to 450, most members of the group will require medical attention. It will lead to serious radiation sickness and will result in about 50% death within 2 to 4 weeks. 450 to 600 are serious radiation sickness in all members of the group. More than 50% death will occur in 3 to 4 weeks. 600 are severe radiation sickness, 100% death in 2 weeks or less. So, we have to again be aware of our surroundings and see what are the different sources, let it be natural or man-made, and what is it the source of these radiations are. If you look at nuclear hazards, radioactive substances are present in nature. They undergo obvious natural radioactive decay in which unstable isotopes spontaneously give out. Fast moving particles, high energy radiation, or even both at a fixed rate until a new stable isotope is formed. The isotopes released either in the form of gamma rays or alpha beta particles. Alpha particles are fast moving positively charged particles. Beta particles are fast moving negatively charged electrons. These ionization radiations have variable penetration powers. So, if you look at it over here, this is concrete, this is lead, this is different thin as well as the thicker version aluminium, and here you have human, and the human hand is considered the next first level of penetration, and finally concrete is the level. So, if you look at the alpha particles, it does not even penetrate the human hand. If you look at beta, it does penetrate to a certain extent. X-ray obviously penetrates the human hand, otherwise we can't use it for medical purposes, but it also passes through aluminium, thin lead, and gamma rays goes right up to the mid level of the thick lead, and neutrons has the capacity of going right through concrete. So, this is the penetrating power of different types of radiation we are regularly exposed to. Now, how do you go about control of radioactive pollution? Number one is time, distance, and how do you shield yourselves. So, first thing is less time spent near the source means less radiation received. Greater the distance from the source, lesser radiation received. And finally, shielding yourself from the source, less radiation received. Control measures, if you look at it, leakages from nuclear reactors, careless handling of during transportation, use of radioactive fuels, fission products and radioactive isotopes have to be totally stopped. Safety measures should be enforced strictly. Waste disposal must be extremely careful, efficient as well as effective. There should be regular monitoring and quantitative analysis through frequent sampling in the risk areas. Preventive measures should be followed so that background radiation levels do not exceed the permissible limits. Appropriate steps should be taken against occupational exposure, and safety measures should be strengthened against nuclear accidents. disposal of nuclear waste. You have high level waste, which is HLW. These have a very high level of radioactivity per unit volume. Since these wastes are too dangerous to be released anywhere in the biosphere, they must either be contained by converting them into inert solids like ceramics and then buried deep into the earth, or are stored in deep salt mines. Medium level wastes like filters, reactor components, etc. are solidified and mixed with concrete in steel drums before being buried in deep mines or below the seabed in concrete chambers. Low liquid wastes, these are like solids or liquids contaminated with very small traces of radioactivity. They are disposed of in steel drums in concrete lined trenches in certain designated sites. Now, if you look at safety measures, you need to monitor radioactivity around the disposal sites, prevention of erosion of radioactive waste disposal sites, prevention of any drilling activity in and around the waste disposal site, periodic and long-term monitoring of such disposal sites and areas of naturally occurring uranium-rich rocks. We will discuss nuclear reactor disasters as a case study. Chernobyl is considered the worst accident in the history of nuclear power. It released more than 100 times the radiation produced by the atomic bombs of Hiroshima and Nagasaki. It affected the Western Soviet Union, Eastern, Central, Northern Europe and Eastern and Northern parts of America. 336,000 people evacuated and resettled elsewhere. Where exactly is the Chernobyl plant? It's in Ukraine, just about 18 kilometers northwest of a particular town, 110 kilometers north of Kyiv. These two are highly populated cities. If you look at the power plant over here, you had 4 reactors of type RBMK-1, but now it is considered obsolete class of graphite moderated nuclear reactor. Reactor capacity was 1 gigawatt, provided about 10% of Ukraine's electricity at the time of accident. So, it had a massive capacity. 2 additional reactors under construction at the time of accident. The series of events in reactor 4 resulting in catastrophic steam explosion, nuclear meltdown and graphite fire. This happened at 11 p.m. the whole incident started, but the control loads were lowered to reduce reactor output for planned testing, but it was lowered too quickly and this leads to an almost complete shutdown. 1 a.m. the control rods were raised to increase the reactor activity for the test. Then at 1:23 the reactor gets overheated, water coolant gets converted to steam, 6 control rods are only left and the minimum safety number is 30. So, you can see the level of reaction from the people of not shutting down the plant, even though it was only when it dropped to 6 that the emergency shutdown button was pressed. Control rods were reinserted, but the fault causes power surge in the reactor. Output becomes 100 times the normal output. So, fuel pellets explode, roof gets blown off, air gets sucked in causing fire. Obviously, when exposure to moisture and as well as oxygen increases the speed of burning and combustion. If you look at the immediate aftermath, area was evacuated but quite slowly. They had an exclusion zone. Tragedy was made worse by poor preparation, equipment and assessment. Radiation was estimated at 20,000 R. The lethal dose is 100 R per hour. True radiation unknown. Fire burned until helicopters extinguished it by actually dropping water, sand, lead and boron. Radioactive cloud was actually observed, like it was completely covered in radioactive materials and not just immediately but for many years to come. Ecological effects was radioactive cloud floated to the easterly direction. Radiation travelled as far as 1100 kilometers. Initial Soviet Union reports was like 60% was contaminated, river was contaminated, fresh water was contaminated, the fish was affected, pine forest within 4 kilometers radius turned brown and actually died. exclusion zone actually became a wildlife heaven. Pretty much everything collapsed. With respect to human effects, 336,000 people were evacuated and resettled. 237 suffered from acute radiation sickness. There were 31 deaths within just 3 months. 9,000 cancer deaths were expected as a direct result of radiation exposure. 4,000 thyroid cancer cases, especially amongst children by 2002. Imperfection reactor design. High void coefficient weakens the convection currents. Graphite tipped control rods increase reactivity for a short period of time. Vertical water channels in the core, temperature gradient in the core, partial containment measures to save costs, operational for 1 year, stored fission by products. So, all of these were bad design elements. Reactor vessel was warped under intense heat, preventing insertion of control rods. Now, moving on to solid waste management. If you go about looking at the different kinds of waste and waste generation, we obviously need to study what is the source of solid waste in India and what is the management methods of how can this solid waste be contained and how is it contained, especially in urban areas. If you look at what exactly is solid waste, it is waste that is not liquid, not gaseous. It is discarded as solid materials from municipal, industrial as well as agricultural activities. The term solid waste refers to anything household garbage, food waste, yard waste and demolition or construction debris. Why should this waste be managed? Waste degrades water, soil, air quality and does environmental and ecological harm. Waste does harm to human health. Waste is unpleasant aesthetically and it creates unhygienic conditions. And the repercussions of waste is just not one-fold. It can be immediate as well as felt after a long period of time as well. What is the objective of solid waste management? The objective of solid waste is to control, collect, process, dispose of solid waste in an economical way consistent with public health protection. Causes are population growth, increase in industrial manufacturing, urbanization. All of these causes together increases the emission of solid waste. Types and sources of solid waste. Depending upon the nature, solid waste can be broadly classified into 3 types: urban or municipal waste, industrial waste, hazardous waste. Now, moving on to the sources and characteristics of industrial waste. So, you have nuclear power plants, thermal power plants and chemical industries. So, these are the main sources, especially where metals and minerals are processed. If you look at hazardous waste, these are the waste that pose a substantial danger immediately or over a period of time to human, plant or animal life. Typical sources are chemical manufacturing companies, petroleum refineries, paper mills, radioactive substances, biological waste, heavy metals and other industries. At the end of this lecture, we have looked into the cause and effect of thermal pollution, the source, cause and effect of nuclear hazards and a basic introduction into solid waste management. At the end of this lecture, we should be able to answer the following questions. What is thermal pollution? What are the main causes and effects of thermal pollution? With the help of a case study, discuss the impact of nuclear hazards. What is solid waste management? That brings us to the end of this lecture. Thank you.